This lesson will cover Unit 2, Acquisition 1 on drawing Bohr models. So last lesson we talked about the difference between a Bohr model and the Schrodinger model. We know that the Schrodinger quantum model is more accurate, but the reason that we see Bohr models more frequently is because it's easier to visualize what's going on in the atom. So first, when you draw a Bohr model, I want you to represent the nucleus with a dotted line. So for this class, anytime you're drawing a Bohr model, I want you to use a dotted line for the nucleus, and I want you to use a solid line for the electron shell. So this is just a personal preference, because sometimes when students use a solid line for the nucleus, they'll also put electrons on that first ring, which is not correct. So now if you use a dotted line for the nucleus and you use solid lines for the electron shells, you can very clearly tell the difference between the nucleus in each of our electron shells or energy levels. Now, I shouldn't see any electrons on your nucleus. When we go to place electrons, they're going to be on our energy levels. I also want you to list the number of protons and neutrons in the nucleus. Please list them rather than trying to draw them. If you are trying to draw in subatomic particles, it's really hard for me to count and make sure you have the correct number. So let's say we were doing a Bohr model for nitrogen 14. Well, nitrogen has an atomic number of 7, so it has 7 protons. Nitrogen also has 7 neutrons. So rather than trying to draw 14 subatomic particles and making sure that I can see the difference between which ones are protons, which ones are neutrons, it's much easier for you just to write the numbers. Electrons go on the shells around the nucleus. Only 2 electrons can go on the first shell. Our second shell can hold up to 8. The third shell can hold up to 18. And I promise I won't make you draw anything this big, but the fourth energy level can hold up to 32. So if this were nitrogen, and nitrogen is neutral, it has 7 protons, it also needs 7 electrons. I can only put 2 electrons in my first energy level. I need a total of 7. So I have 1, 2, 3, 4, 5, 6, and 7. All right, let's just do one together. Let's draw a Bohr model for, let's do an ion. Let's do chlorine 35. first, chlorine has an atomic number of 17. Atomic number is equal to the number of protons. Chlorine has 17 protons. If I take my mass number minus my atomic number, that will give me the number of neutrons. So 18 neutrons. And again, please write the numbers rather than trying to draw 35 particles in your nucleus. Much easier just to write the numbers. Electrons. First, let's figure out how many electrons we have. Well, chlorine has 17 protons, but its charge is -1. That means chlorine must have 18 electrons. I have one more electron than proton. If I had 17 positives and 18 negatives, that gets me to that charge of 1 minus. So I'm going to use a solid line to represent my first energy level. And we said we can only put 2 electrons in that first energy level. 1, 2. So we're going to add a second energy level. We use N to represent the energy level, so N equals 2. My second energy level can hold up to 8. So I already have 2 placed. 3, 4, 5, 6, 7, 8, 9, 10. So 2 in the first energy level, 8 in the second energy level gives me 10 total. I need to get up to 18 electrons. So we are going to add a third energy level. N represents energy level, so this would be N equals 3. So far we placed 10. Here I can go up to 18. But we placed 10, I only need 8 more. So 1, 2, 3, 4, 5, 6, 7, 8. So this would be our complete Bohr model. I have the correct number of each subatomic particle, 17 protons, 18 neutrons, 18 electrons. I have my nucleus represented with a dotted line. I have my energy levels represented with a solid line. Clearly have the nucleus and each energy level labeled.